email it to me when we're done.
Thank you. Now I can stop coloring this because it doesn't match my project.
Okay, so I'm going to be on paper, but you're going to be on multiple choice part A. Multiple choice part B will be on you to finish. And your first question should be, well, okay, this one.
Wait, what? I got the wrong one.
Okay. You got the wrong one?
Yep.
Where? Ours looks like a graph.
A free response.
You're probably on the free response.
Unit.
Yeah, go to multiple choice part A. MCQ, multiple choice questions, part A. Yes, you will need some scratch paper for some. Not all, but some. Okay, now does this match your screen? Okay, so notice that this has a little calculator by it. If you do take the AP exam, which we'll have to make that decision in a couple weeks, the calculator section and the non are totally different parts of the test. It won't alternate back and forth between problems like this. So there will never be a question on whether it's a calculator question or not. You will know because the whole section will be the same. But anyway, this one has a calculator by it. So, and looking at those answers, I can tell I'm going to need my calculator, right? Those are some funky, really odd decimals there. So, and that is my first suggestion on these multiple choice. Always glance at the answers first, because sometimes you only have to set things up and you don't even have to finish it out. So always glance at them first. Okay, the derivative of a function f is given by f prime here. At what value of x for x greater than 0 does the line tangent to the graph have a slope of 2? How am I going to do this?
Plug in the 2 for the x.
Okay, do I want to find f prime of 2?
No, we already have it.
You want to find f prime equals?
Right, we want to know where f prime equals to, because f prime, the derivative, represents the slope, and I want to know where the slope is 2. So I want to know where 2 equals 0.1x plus e to the 0.25x. All right, and clearly that's not something we're just going to know off the top of our head, so that's what makes it a calculator question. So go to your calculator, let's make this y1, just y equals 2, and then make this one y2, so that you're setting up 2 equations, one for each side of the equation. And this is what my graph looks like. Yeah, so if I want to know where 2 things are equal, this is one way that you can use your calculator to find that. You're going to graph both sides as separate equations, and then you're just looking for where they are intersecting. So clearly there's one point. I don't know that I could guess that point. Well, could we? Could you tell what the answer is just from looking? It does. If I had to guess, I would say it's the 2 number. But let's just double check so we know how to do it. We're going to go to that second trace menu, that calculate. I want to find a point of intersection, and we're going to hit enter 3 times, and it should take us to that point.
Yep.
Wait, do you have to move it?
You don't for this one unless you have multiple graphs that you don't need on there. If you just have the 2 that you're interested in, then you shouldn't have to move the cursor. Okay? All right, so that one should be C. All right, next one also has a little calculator by it. So let's see what it says. Let f be the function given by f of x. Selected values of f are given in the table above. If the values in the table are used to approximate f prime of 0.5, what is the difference between the approximation and the actual value of f prime? Okay, read through that again. See if you can figure out what we need to do.
Take the derivative of f of x and plug in 0.5.
Okay, that is definitely how we will find this. Take the derivative of f, and we don't have to do it by hand, right? Remember, this is a calculator problem, so it can do it for us, and we want to plug in 0.5. So I want to find f prime of 0.5. I will definitely use my calculator for that. And then what do I want to do with it? Here's the question. What is the difference? Difference means you're subtracting between the approximation and the actual. This will give me the actual. How do I find the approximated slope or derivative?
1 minus 0.
Yeah, I'm going to use these two ordered pairs that I'm given. Remember, I want to approximate the slope at 0.5, which is halfway between 0 and 1. So I'm going to use the slope formula,
So 2
which happens to be
minus
right here,
1.
with these two ordered pairs. So I have 0, 1, and 1, 2, and I'm going to use my slope formula. That will give me the approximation. So 2 minus 1 over 1 minus 0 is just 1. Okay, now let's talk about how we find the calculator's derivative. Do y'all remember? Okay, let's go to a blank screen. All right, go to your math menu and find derivative.
Wait.
Math 8.
Oh, yeah, got it.
Okay, now ddx is what we need. This is where I type that function in. So it is 2 raised to the, is that x squared? X cubed, thank you. It's printed so tiny. And I wanted it x equals 0.5. And did you get that?
Yeah.
Okay, 0.5669. All right, difference between those, you're going to subtract them. And which answer do we get?
B.
I agree.
So you subtract the 0.669 from what?
0.5669 from 1, from the approximated slope that we got. Okay? Questions on that? The hardest part on these is not usually the math, it's figuring out what they're asking. Mm-hmm.
So why are we getting so clever with that on the chart, even though it just says F and I?
Okay, so these are 2 points on the curve. So I don't know what my curve looks like, but they go through these 2 points. So, I mean, it might look, who knows what it looks like. But if I want to approximate the slope halfway between, one way I can do that is just to find the slope of that segment between those 2 points. And that, of course, is our slope formula then. So an approximation, when they give you a table, you're just using slope formula. You just got to pick the right 2 order pairs. In this case, we didn't have to pick because we're only given 2. All right, next page. Next question, number 3. Oh, check out this function. This is just being annoying. Look at that. That's ridiculous. Okay, so we have this huge function f of x, and we want to find the statement that is true. Okay, look at your answer options.
A.
What are we doing? Just gonna throw A out there and move on, Cole, huh?
Yes.
Let's slow down a bit.
Saying in the range.
Saying just finding the derivative and which one's greater.
Yeah, so there are how many? 3? 3 different derivative values here. And basically they want us to rank them. Which is smallest to biggest or biggest to smallest? Smallest to biggest, because this first one is smaller than that one, which is smaller than that one. So what I really need to know is, what are these 3 values? F prime negative 1.5, F prime of 0.4. Okay, now I have 2 options here. One is to graph f prime, and maybe I can just tell by looking on the graph which y value is bigger and smaller, or I can actually calculate these on the calculator. I think I would calculate them because I don't know if the graph is going to be that obvious. There might be two values that are super close. So your first step is to go to y equals and type in this messy thing. Okay? Type it into y equals.
So why can't we do the derivative thing again?
We could, but what if... I am good. I see what you're asking. I am. But do you want to type that in 3 times? You would? Oh, I don't. I want to type it in once, and then remember that y vars that we can use, and it'll pull the equation in. That's what I'm doing. Yeah, sorry, I should have explained it. And that's why I did not delete it from last one. Alpha y equals, get your fraction. Remember, if it's 1/2, do 0.5. You changed your mind now? So once you get it typed in Y1, then go back to a blank screen. Okay, so what I'm going to do then is I want to go back to that math menu and I want to find derivative. d dx. Now, this is where I don't want to have to type in that equation 3 times. So I already put it in as y1. So I'm going to go to vars, y vars, function, right next to clear. Okay, so I went vars, over to y vars, function, and then just choose y1. And then you don't have to type all that in again. And where do I want to evaluate it? The first one I wrote down was negative 3.1. And there we go.
Wait, so why would you have to do it 3 times? Why wouldn't you just go back up and press enter on that one and change that value?
Yeah, that's what
It might let you do that.
it does.
Okay. Still, you're typing it in once, which I did also.
How do you get the Y1 million?
Vars, which is right next to clear. Go over to y vars, function, y1. Okay, so then do that again for negative 1.5 and 0.4. Okay, I'm going to do it so those are friends watching from home. Let's see how I'm doing it. See, those two were close, so I don't know if just graphing and looking at the derivative would have been clear to distinguish those. Maybe, maybe not. Okay, so which one will be my answer?
D.
Okay, so this one, the derivative of 0.4 is the smallest, so that would have to match up with D.
I chose the A before because I was looking at the graph and was plugging in the derivative. I didn't take the derivative of the functions.
Gotcha. Okay.
Because if you do this exponent, whatever is bigger will always be bigger.
Okay, fair enough.
So for these, like, there's a pattern, obviously, because there's the biggest, middle, and then the smallest,
Mhm.
and then
The answer choices?
Right.
Mm-hmm.
will that always?
No. Mm-mm.
Okay.
No. Just depends on what the function looks like. Okay, so let's go to question 4. Selected values of a function f are shown in the table above. So we're not given an equation. We're just given ordered pairs. What is the average rate of change over the interval 1 to 5? What do I need to do?
Slope.
Slope formula between 1 and 5. So what does that determine? Which ordered pairs I use. So I'm using the ordered pair here and the ordered pair here. Average rate of change just means slope formula. So make sure that you put your y's on top. Now, guys, look at the answers. We don't actually have to find it, do we?
Nope.
So y minus y over x minus x, and we should find that answer in
C.
C. I like those when you don't actually have to do a whole lot. Are we good on that one?
Yep.
Okay. Be sure you're marking the right answer. I had some people last blocks. I didn't get a 100. I typed in the wrong number. Okay, the graph of the function f is shown above, consists of 3 line segments. What is the average rate of change, aka use slope formula, over the interval -1 to 6? Okay, what 2 ordered pairs am I using?
-1, 0, and 6, 0.
All right, just look at those points. Do I need to do the slope formula?
Nope, 0.
Yeah, if I connect those, that's horizontal, slope is 0. Now, if you want to, use your ordered pairs and plug them into the slope formula. But we know because it's horizontal, the slope would be 0. We good on that one?
Yep.
All right, number 6. The function f is given by f of x. What is the average rate of change of f over the interval 0 to pi? Is there a calculator by this one? No. Average rate of change means what?
Slope formula.
Slope formula. Okay, what are my 2 ordered pairs?
0.
Well, 0 something and pi something.
Plug in 0.
Let's look at our unit circle. All right, guys, where is 0? Wave in the air.
Right.
By the windows.
The cosine is going to be
Ordered pair is 1, 0. Cosine is x, sine is y. Where is pi?
the other one.
The other way.
So
West.
0, 1, and -1.
Okay. Cosine is x, sine is y. Okay, so let's find f of 0. That will be 1 plus 3 cosine 0. Well, cosine of 0 is 1. So I get
4.
4. And then f of pi is 1 plus 3 cosine pi. 1 plus 3 times -1 is -2. Now let's use our slope formula. So I have -2 minus 4 over pi minus 0 is which answer? A. -6
The
over pi.
second one in that interval is like x2 and y2.
Yes. No, x1 and x2. Is that what you meant? Yep. Yep. These are the 2 x values. Then we have to find the y values that go with them, if they're not given in a table. Question? All right. Macy, question? Question 7. The derivative of the function f is given by f prime of x, and f of -1 is 6. Which of the following is an equation of the tangent to the graph of f at x equals -1? What do I need to do? Look at your answer choices. We're writing an equation of a line, right?
Yep.
What 2 things do I need to write an
The
equation?
slope and a point.
Do I know either?
Yes.
No, you don't know the slope.
Well, we not the slope.
I have a formula for the
You
slope.
know the point,
I do know the point.
you don't need the slope, so you just don't
But you can find the slope.
-1/6 is the point. Now I can use that point and evaluate the slope at -1.
Why did they put it in like the y equals? Why don't they leave it like you leave it most of the time?
Just they'll do both. But to get it in this form, I'm going to use point slope.
Is there any reason why one is better?
If you're graphing, this is better. But other than graphing, no. Let's see, that's 3 plus 4 is 7. So that's our slope. Look at my answers. That automatically eliminates 2 of them, doesn't it? So now I'm going to have to say y minus 6 equals 7 times x plus 1. And like Abby said, they did put this in slope-intercept form, so I'm going to have to solve this for y. But this isn't hard. We can do it. Add 6.
13.
And that gives me which answer?
D.
D. Question? Alrighty. The graph of f prime. This is not the graph of f. This is the derivative of f. Points 2, 6, and 4, 18 are on the graph of f. Which of the following is an equation of the line tangent to the graph at x equals 2? Okay, again, the two pieces of information I need are a point and the slope. I have a point. Which point do I need to use?
The 2 on the derivative graph.
2, 6. How am I going to find the slope at 2? Okay, so I can't use slope formula because I don't have 2. Oh, yes, this is the derivative graph. So if I want to know the derivative at 2, I'm going to go to this ordered pair, 2, 5, and that tells me that the slope is 5.
So why can't you use the slope formula?
Because the slope between these 2 points may or may not represent the slope at that point. Well, okay, for example, what if I had a graph that was like this, and 2, 6, and 4, 18, let's say it's way up here. Okay, I can find that slope, but that in no way is close to the slope of the tangent right there. This point is given to you for no reason. It's extra information.
Yep.
Love it, right? So, I know that my slope is 5, so I have y minus 6 equals 5 times x minus 2. And again, this is in slope-intercept form. And 6. And we get B. Question? Okay, so what do you think? How would you be doing so far on your own?
Okay.
Like think about it seriously, because in a couple weeks we have to decide about the exam. And so this is how they're presented. So just kind of be thinking like, okay, how do I feel about this? It is on paper this year. It might be the last year that it's on paper. The graph of the trig function f is shown above between a and b. At which of the following points on the graph of f could the instantaneous rate of change of f equal the average rate of change of f on the interval a to b? Say what?
Yeah. Maybe A
Okay.
to B.
Let's talk about instantaneous rate of change. What does that mean?
At one point.
At one point, what is the slope of the curve? I want to know when that equals the average rate of change, slope formula, from A to B. Okay, so if I went from where x is A and where x is B, and I found the slope,
I thought it was talking about A.
see how it has little a and little b?
Yeah.
That's the domain. So it's like saying from 2 to 8, right? So it's the beginning point and the ending point. All right, so that dotted line would represent that average rate of change. What this question is asking is, at A, B, C, or D, would the slope be the same as that green line that I just drew? It's definitely not A. What's the slope at A? 0. It's definitely not D. Why?
D's positive.
D is positive. So that knocks it down to B or C. So imagine drawing a tangent line at B
I think it's B.
and a tangent line at C. Which one would be slanted just like this one?
C. B.
B. Because a tangent at B would have to skirt along like that. C would look something like that. So B would be the correct answer there. Again, that's not a hard question, but interpreting what you're being asked is the tricky part. Okay, which of the following statements is, if true, can be used to conclude that f of 2 exists? That means there is a point at x equals 2. Okay, number 1, the limit approaching 2 exists. So if I have a limit, does that guarantee there's a point when I get there? No, we did lots of limits where you had an open circle, right? Where you were approaching an open circle and the limit existed even though I didn't have a dot there. Okay, so that doesn't guarantee that we have a point. F is continuous at x equals 2. Does that mean I have a point at 2? Yes. Remember, continuous means you can draw it without picking up your pencil. So if I can draw it through 2 without picking up my pencil, there's an ordered pair there. Okay, so this one is yes. F is differentiable at 2. Opposite. If it's differentiable, it has to be continuous. Now, when is it continuous and not differentiable? That's like corners and cusps. So both of these have to be true. And so our answer would be C. All right, here's another one of true or false situation. Question 11. Let f be the function defined above, which is this piecewise. Which of the following statements is true? F is neither continuous nor differentiable at 2. F is continuous but not differentiable. F is differentiable but not continuous. F is both continuous and differentiable. How am I going to find out? Okay, we definitely need to plug in 2. Why? If it is continuous, they're going to connect, right? Now, clearly the point that they might break is at 2. If I graphed 3x plus 1, what would that look like? A line with a slope of 3. This one would be a line with a slope of 5. So I could have like 2 lines that are totally not connected, or I could have 2 lines that are connected somehow. So that's what we're determining. When we come into 2, are they connected or not? So the way I'm going to find that out is what you suggested. Let's find f of 2 in both parts. That one gives me 7. That's 10 minus 3, which is also 7. Okay, so clearly they do meet. So that tells me I'm looking for answers that say what?
Continuous.
Continuous, I know, right? So it can't be this one, and it can't be that one. So I know it has to be continuous. Now the question is it differentiable or not?
No.
Okay, it's differentiable if I have the same slope coming in at that point.
You don't.
I don't, because we just said this one has a slope of 3. This one has a slope of 5. We're not approaching the same slope as we get to x equals 2. So it is not differentiable. It's going to be a corner. It's going to be a corner situation like that. So this one would be B. Does that make sense?
Yeah.
All right, lovely graph here. The graph of the function f shown above has a vertical tangent at x equals negative 2. Okay, x equals negative 2, vertical tangent right there. And a horizontal tangent at negative 3 and negative 1. So those have slopes of 0. Which of the following statements is false? F is not differentiable at negative 2 because the graph has a vertical tangent. That is true. F is not differentiable at 0 and 2.5 because it's not continuous.
True.
That is true. F is not differentiable at 1.5 and 4 because of sharp corners.
True.
That is true. And if we would call it a cusp, maybe there, that is still the same type of issue. So the fact that they're calling that a corner is okay. Let's hope it's part D. F is not differentiable at negative 3 and negative 1 because there are horizontal tangents.
False.
Yes, that is false. It is differentiable. The slope is 0. So that one would be D. Good. All right, next one. 13. Oh, we don't even need to write this down. Find that derivative for me.
C.
Don't listen to Cole. He doesn't always know what he's talking about. Do we agree? Yeah, that's a piece of cake, right? Give me 100 of those, please. Next one. Find that derivative. That's kind of like something we did on the test. Oh, don't tell them the answer. How would you rewrite it first? X to the negative 7. And now find your derivative. Don't call it out. A, B, C, or D?
D.
D. We could eliminate A and C because those coefficients are 1/7 instead of negative 7. All right, same kind of thing here, just find the derivative. What do we think?
C.
C? I agree. Question?
Nope.
All right, yep, submit that one. So again, you have another set of multiple choice to handle on your own. Next, I want you to go to, after you submit that, go to the free response question.
Part A.
Mm-hmm. You should only have one free response assigned, right? All right, so here we go. All right. We're going to read through this just so you can, this will appear on every exam. You are permitted to use your calculator to solve an equation, find the derivative of a function at a point, or calculate the value of a definite integral, which you don't know what that is yet.
Oh.
However, you must clearly indicate the setup of your question, namely the equation, function, or integral you are using. So in other words, what they're saying is if you do everything on your calculator, you have to just show the equation that you're setting up on here. Okay? You don't have to show the work, because clearly some of these, the calculator is going to do all the work for you, but you have to communicate what you're putting in your calculator. Let's see. Answers without supporting work will usually not receive credit. Unless otherwise specified, answers need not be simplified. We've been talking about that. If your answer is given as a decimal approximation, it should be correct to 3 places after the decimal point. That's our truncate after 3. Or write more than 3. Unless otherwise specified, the domain of a function is all real numbers. Okay. Here is the graph of f. Welcome to the graph of f. Let f be a continuous function defined from -1 to 8, whose graph consisting of 2 line segments is shown above. Let g and h be the functions defined by g of x and h of x. Okay, so far we have a function f that's only given in graph form. We have a function g and a function h that's given explicitly. Here's an equation for it. Now, the function k is defined to be f times g, and we want to find k prime of 0.
You have K. Where's K?
K is that product. Now, do I actually want to multiply those out?
No.
Heck no. But can I find the derivative?
Product rule.
Product rule. Yes. Okay, so let's set up if k of x is f times g. I mean, if they were easy to multiply, then I'd say yes, let's go ahead and multiply them and then take the derivative. But they're not easy to multiply. So I know that the derivative of k will be whatever the product rule gives me. So f prime times g plus f times g prime. And I want this x value to be 0. So k prime of 0 is f prime of 0 times g of 0. F of 0, g prime of 0. Okay, now somehow we got to figure out all these values. F prime of 0, we might need to, but here's function f. How can I find the derivative at 0?
Go up.
The slope. I can't take a derivative here because I don't have an equation, but derivative represents slope. So at this point where x is 0, what is the slope?
2.
And I find that just by counting rise over run. So over here, the slope is 2. All right, should we go ahead and find the slope over here while we're at it? We might as well, because I bet we're going to need it. Negative what?
Oh, sorry.
Wait.
Negative what?
2 over 3. I'm sorry. It's all okay.
You good, Aiden?
Which one are we finding the slope for now?
I found the slope of both sides,
Why?
in case we need this slope over there.
Oh, just that whole line?
Yep, that whole side,
Oh, I see.
using rise over run. Okay? All right, so when I need f prime of 0, it's going to be 2. Okay, g of 0. Well, that means, oh, go to function g, plug in 0. You can do that in your head. What do you get?
0,
Square
0.
root of 3.
Square root of 3. Okay.
0 would be
2, 3.
F of 0 is whatever the y value is there.
3.
So that's 3. Okay, g prime of 0. We got to do a little bit of work, don't we? Take the derivative of g, then plug in 0. Okay, so I'm going to come down here and find g prime. I'm going to bring the 1/2 down. Chain rule. Let's see, 2x minus 1 over 2. Alright, does that make sense there?
Why did we, for the derivative of f,
Can you leave it as negative 1 over 2 square root of 3?
Yes. So I'm going to plug in 0 now. That will give me 0 minus 1 is negative 1. 2 times the square root of 3. Yes, we can leave it.
I know we're not supposed to just like go and say g0 is square root of 3. What, like, I know that we're not supposed to just find the derivative of that, but why?
Wait, what?
Like, we're finding g prime of 0, so like, why can't we just take the square root of 3 and then g0 and the derivative of it?
Oh, okay.
I know we're not supposed to do that.
Okay, right. So if you plug 0 into this, you're not finding any kind of derivative. You're just evaluating that function at 0. You're finding an ordered pair on that function. It has nothing to do with slope. You see what I'm saying? It's like if you were going to build a table of values so that you could graph it, and you said, okay, well, let's plug in 0. I get square root of 3. Okay, that's one ordered pair on the graph. Okay? Okay, so if I take this crazy number, now, you can leave it. You can stop there.
Can we like that?
Or you can type all that in your calculator and turn it into a decimal at least 3 places. Okay?
If you
But now we gotta type this?
I just did it.
Yeah, okay, on this, type in we did in class. Okay?
Thank you.
Wait, okay, well, what would we type?
Okay, so on this, I assume when they do have this online, they're going to give you some options. You know, on Delta Math, if you ever worked on Delta Math, how they'll give you square roots, symbols, signs, things like that. you could do like that, and that could
Wait, so
mean
we don't have to
square root.
explain, like, how we did it?
Yeah,
We just
not
have to
not on
type
this
our
right
answer.
now. We just want to go through it. So just type for right now on these problems we did in class. That's it.
So on our answer, I didn't know we had to solve. So like, you do -3 over 2 squared root of 3, and then if you multiply the other side by 2 squared root of 3 to get common denominators.
I would never do that on the
I
exam.
just don't know if I did
but
that.
yes, you're right.
And then you get 12 over 2
Mhm.
squared root of
Mhm.
3 minus 3, so it'd be 9.
You got it. Yeah. Good. Yeah, but on a test, don't do it
I know, I
just in
wanted to
case
know
you
if I
make a
did it
silly
right.
mistake. But you did it perfectly.
So do you have to explain how we do things?
Okay, so remember this is going to be a paper exam. So what you would need to do on your paper exam is just what we did right here.
Oh, okay. So we
And then
won't
you would
have to-
say, here it is. That's my answer.
We won't have to type out and explain how we did it.
It'll be on paper.
Oh, yeah, this is what this
It'll
is
be on
better than
paper.
stats.
It'll be on paper. Okay, now sometimes we do have to write simple statements if it says justify your answer or how do you know it's going to be blah, blah, blah.
I did the
Then
work.
sometimes, but they're not looking for a paragraph. They're looking for very concise because the slope was positive, things like that. All right, so let's tackle part B. A new function. The function m is defined by f over 2g. We want to find m prime of 5. Quotient rule. Oh, let me point out this. Does part B have anything to do with A?
No.
No. So when you are looking at a free response, if you don't know A, it doesn't mean you can't do the rest. Because often all parts are independent and they don't necessarily get harder as they go along. So don't ever read part A and go, well, I'm screwed on this one. That's it. Like, you got to read them all. C might be the easiest part. And it would probably have nothing to do with the other two. So don't give up hope. Read them all. Yep, 2 coefficient goes with it. Okay, so I'm going to do... Y'all are going to be sitting in there going, low-D high.
UV prime.
Okay, now our x's are all 5s. I'm going to have a 5, and a 5, 5, 5, 5. Okay, so everything that I'm doing would be your work that you're showing. Okay, so we need to find g of 5. How would we do that? Plug 5 into g. Now, you may not trust yourself. You might want to check that on a calculator. Just leave it as a radical. Square root of 23 times 2. Okay, how do I find f prime of 5? Here's f. Yep, we already found the slope. So f prime of anything to the right of 2 is negative 2/3. Minus f of 5. Well, that's easy. Here's a graph. If I go to 5, the y value is also 5. And g prime of 5. Oh, remember we found g prime. It wasn't pretty, but we found it. Here it is. So if I want to find g prime of 5, that's going to be 10 minus 1. 25, 23, 9 over 2 square root 23. Okay, that's a nice number. We'll go with it. And don't forget your big denominator. G of 5, we already found that, right? That was square root of 23. So I have 2 square root 23 squared. You can leave it, or if you want to type it all in your calculator and get a decimal, you can. Okay. The only thing I might simplify is those 2's do cancel. And I could make this negative 4/3 square root 23 minus 45 over square root 23 over 4 times 23, which is 98. And I would not go any further than that. You can stop there. All right, last one. Find the value of x for... How did I get 90?
Is it just 4 times 23?
Yes. Did I multiply it wrong?
No,
Okay.
I was wondering how you did
Yes,
that.
4 times 23. All right, find the value of x between negative 1 and 2 such that f prime of x equals h prime of x. Okay, well, f prime of x only has 2 different values, 2 and negative 2/3. What is h prime of x? Did we find it?
No.
We have not found it yet. H prime, oh, that's going to be an easier derivative, isn't it?
Yep.
Let's find h prime. What would it be?
5bx minus 9 cos of x.
Okay. Okay, so that's h prime. This is asking me, between the values of negative 1 and 2, where is the derivative of f equal to this? Okay, well, the derivative of f is either 2 or negative 2/3. Because of our graph up here. Okay, so I only have 2 slopes up there that exist. And this question is asking me, where are those 2 derivatives equal? So where are these equal, and or where are these equal? I don't know where those are equal, but what can we do?
Solve for x.
Put it in the calculator.
I don't want to do that. Yes, use your calculator. Just like we did on the first one, make that y1, make this y2, and let's see where they intersect.
It's the x. Just find the value between negative 1 and 2, and that's just m equals 2, so why would you do the negative 2/3?
For m equals 2.
Like that's on the graph.
No, but the
slope.
x value is going to be between that, not the slope. Do you see what I mean?
But the x values between them, the slopes that are negative 2 and 3. You know what I'm saying? The x values that are in between negative 1 and 2 are always going to have a slope of 2. So why would you do negative 2?
Right, but, okay, so I want to basically look at the graph of this and the graph of this and see where they cross or intersect, and what is the x value where they intersect. Does that make sense? So basically what you're saying is, okay, on this graph, where does y equal 2? Where does y equal that same slope? So that's going to be a point or points of intersection. And then I want to do the same thing, but with negative 2/3. Okay, let's graph them and see what they look like. Anytime you are typing anything in your calculator with a trig function, you need to make sure what?
Radians.
Radian mode. So check your mode, make sure you're in radians. Okay, let's go to y1. Oh, let's see, I already have these down here. Okay. So make one equation 2, make the other equation 5 e to the x minus 9 cosine x. Hello? Did I not turn it on? Oh, it's not turned on. All right.
So you just do the first one that's in between negative.
All right, this is what I'm going to do because I only need between -1 and 2. I'm going to set my window to go from -1 to 2 so that I don't pick up any points I don't need. So it's going to be a little narrow window of what we just saw. That's it. That's all that I'm interested in. Is so they intersect at one point. So how do I find that point? Yep, second trace, find that calculate, intersect, 1, 2, 3. That's one solution. X equals 0.622. Okay, now let's do the same thing, but change this to -2/3. And graph that. It should look very similar. That horizontal line is just going to be shifted down. Here's my cosine curve. There's the horizontal line. Again, only one point of intersection, so let's find that. Okay, I'll go back and try to clear that up. 0.417.
414.
414, thank you. Okay. All right, so the reason
The trace thing, I don't know.
Don't use trace.
For the second trace.
Oh, okay. Because trace just jumps around however it wants to. So you go to second trace, intersect. And then it'll ask you first curve. You just push enter, second curve, enter one more time. Okay, so why we had to set this up both times is it because it said find the value of x between -1 and 2, where the derivative of f equals the derivative of h. But the derivative of f equals two different numbers. Everything over here has a derivative, aka slope of 2. Everything over here has a slope of -2/3. And that's it. You find no other slope on there. So that's why I had to set it equal to both of them.
And now we submit.
Okay? Any other questions on that one?
So why do you have to use the second slope if it's only looking for it in between -1 and 2?
Okay, but it's looking for the x value where the slopes are the same, not from this graph between those numbers. So you're setting those slopes equal to each other, and you're looking for points of intersection that fall between these two
It's
numbers.
just not asking on that graph.
Right. It's asking about these two graphs. Okay. Anything else on that one? Free response is tricky. Okay, so you guys have 25 minutes. I would go ahead and start on those other multiple choice questions so that you can ask questions.